Hello. In this video, we're going to be looking more into Dart and Flutter, but we're going to be focusing more on Dart programming. We said in the previous video that Dart. So, in the previous video, what we said was we did an introduction to Dart and Flutter, and we said okay, Dart is a programming language that can be used, for writing applications, and Flutter is like the platform that can be used to write those applications in that programming language, right? And we said Flutter is used to develop cross-platform applications. What does that mean? Right, with Flutter and Dart, you can write applications for Android, for iOS, for desktop, for web. So with one programming language and one platform, something like that. You don't really need to know those individual ways of writing code, right? You don't need to know those ones, but with Dart and Flutter, you can write from one place, right? Before you can start developing cross-platform applications using Flutter, you need to know the language, you know, Dart, which is what is used in writing applications, right? On Flutter, right? So what is that programming language? That programming language is a high level object programming language, right? That you can use to write applications, you Flutter application develop applications using Flutter. So what is a high level object oriented programming language, right? So basically high level languages are like this is how it is, right? So you have a computer, and what a computer understands is ones and zeros, right? The computer does not understand what we humans understand. So you want to give the computer instructions, right? Which is programming. You're writing instructions for the computer to carry out, to solve issues, right? Do carry out tasks. So, in order for you to tell the computer what to do, you need to understand the language. It's like you go to a foreign country. If you don't know how to speak their language, how would you get along? Before the age of technology, you need to either know how to speak the language, or you need to take along with you an interpreter that will translate whatever you say to the language that the people there understand, and then they can carry out whatever you want. So something like that. So one and zeros are what the computer understand, and it will be very difficult for us humans to be able to learn one and zeros because there are a whole lot. So some group of programmers developed what we call assembly language, right? And then this assembly language was like a bridge between learning one and zeros. You didn't have to learn one and zeros anymore. You just had to learn assembly language, and it will be translated to one and zeros, right? But the assembly language was still quite difficult for humans, and then high level of programming language came on board that were like English, like human like, right? I'll use the word human like. So you could, for instance, in English language, so you could write programs in something like English, and the computer, either through a compiler, or any other translator, will translate it from what is written in English like statement to what the computer understands, which is one and zeros, right? So basically, that's how this works. So let's actually get started with that programming language, right? So for us to understand that programming language, we have to learn some of the syntaxes. And I'm going to be using an online um, um, let's say online that compiler or something we could use to write that online. I'm going to use this, right? So we can use this to practice and understand that better. So basically, when you actually start your application, right? You actually start your application. When you come to that, you have this main function, right? So step by step, we're going to be understanding everything. So let's just see the main function as the entry part. Let's just say it's the entry part of a program, right? What do I mean by entry part of a program? Okay, so it's more like if you want to get access to your house, you need to like open the door and come through the door, right? So if you want to run that application, like you want to write that, you want to program in that, you need to the entry point of the Dart program is this main function, right? So that's what we are seeing here. That's why you have this. If we just click execute, you're going to see something on the screen, right? We can see hello world, right? Because that's what this does. So what this basically does, this is a function. And we're going to get to functions much later, but this is a function, and what this function does, it just outputs hello world. Whatever you put in here, right? It just outputs it right to the terminal, to the screen. So let's actually get down to business, right? So if you want to work with, if you actually want to work with that, let's start with variables, right? So what are variables? Variables are simply ways for you to store data. What do I mean by that? So if you're a chef or you like cooking, right? I believe you would have a container where you would store salt, right? So that container is what holds the salt. So the value of what's in the container is salt, but the container itself, it could be of plastic, right? So that is a container. You could use that container to store sugar too. You could use the container to store pepper, whatever it is, but there is a container, right? So that container is called a variable, and what it holds is salt, right? If it's salt in salt case. So how do you create a variable? How do you create a variable in that, right? So there are basically different types of variables, right? So you have there's integer, right? So let's create integer variable, right? So I'll just comment this. So what is this, right? This is a way to comment a program. What is comment in that, right? So let's say comments are non-executable code, right? So like the compiler is going to actually see them, but it's not going to execute it. It's going to just take it as notes, right? This is another example of comments, but this is like for multiple line, because you can come down and still write something, and you can see that it's still showing in blue, right? So basically that is that. But with this, you can't come down like this. It has a single line, right? So how do you create an integer? Integer is used to store integer values, right? So you use the keyword integer, and then the name of the variable, right? So what's the variable name? Let's just say a is equal to then 1. So you would specify the type of data, and you would specify the name of the variable, and then you have this equal to sign, which is used to assign value to a variable, and then you have the value, which is 1 in this case. I have a semicolon at the end, right? So that is how you create variables, assign values to variables, right? So we come and we say print a, and then we're going to have this 1. It's printing 1, right? So we can see that. So that's how you can actually create an integer. So when you want to create a variable, there are various ways you can name a variable, right? So there are rules, right? You can't use a keyword. What is a keyword, right? This is integer, so you wouldn't use integer to name a variable, right? Keywords like that. So we'll be coming across more and more keywords. So things like bool, and the rest are all keywords, right? Reserved for the compiler, right? Then the variable name starts in small letter, right? So if you want to actually differentiate, the different words, you can say something like number 1, which is camel casing, to use to differentiate it. You shouldn't have space in variable names, right? So these are some basic rules, right? Because the goal of this video is to keep it as basic as possible. So those are the rules, right? For the basic rules for some of the basic rules for creating variables in that programming language. So we also have double, and double, as you can guess, is used for storing floating point numbers, right? So you could say double, let's say weight, and would say equal to 35.5, right? So that will store a weight, right? We could say string. So string is used for storing, is a data type, and these are all keywords too, used for storing let's say text, right? Something like that, like somebody's name, you will use a string to store that, right? So let's say string first name is equal to, I will say John, right? So that will be that value, right? And then bool is a type of value that stores either true or false. That's the only thing it stores, right? True or false. So how does a bool work? It only stores true or false, right? In what sense? Okay, let's look at this like this. We can have bool, and let's say is student, equal to true, and it could also be equal to false, right? So those are the only two values of a bool that a bool can store, right? Those are the only two values that a bool can store. So we're going to look at operators in that programming language, right? Arithmetic operators and expressions, right? So let's look at the first operation. Let's look at these operators now. Arithmetic operators. We can use them to perform operations on numbers and strings in some cases, right? So let's say integer a equals to 1, integer b equals to 2, integer sum is equal to 1 equals to a plus b, and we say print sum. So when we do that, what do we see? You can see that, right? So the reason why I'm showing this one is because of this. So if I comment this out and I click execute, you can see 3, right? So this is a way you can add numbers. This is an arithmetic operator for adding numbers. So when we say subtract, you can have this, you have this, right? You can see that, right? And when we say multiply, you have this. So basically, that's how you can do that. And when we say divide, you have this. So now it's bringing an error. Why? Because 1 divided by 2 is 0.5, right? So you cannot store a value of type double in type integer. So how can we address this issue, right? So we just change here to double. We change here to double. And once we change that to double, you would see that automatically takes care of that, right? And that is that on arithmetic operators using that, right? So but we can also perform it on strings. Well, in this case where we have first name, we can come here and say string last name equal to James, let's just say Doe, right? And we say print first name plus last name, right? That would work. Let's see, that should work, right? And cute. All right, so you can see that John Doe, right? So that actually shows here, right? So that's how you can join two strings together, right? To make them one. So in this case, I could just literally put this and then put an empty and do this, and then when I do that, to give the spacing, right? So that's how you can join two strings, right? So the arithmetic operators can also be used for that. So what about relational operators? What are relational operators? They are used to compare two values, right? So you can use them to compare two values. Let's say, for instance, right, we can say print, right, 5 equal to 5. Now let's watch what will happen. And we say that true, because 5 is equal to 5. So this is like a way of checking, is the first value here equal to the second value? If it is, right, it's going to be true, right? So if we put 6 here and we put 5 at the other side, you can see it's false, right? So that is that. We have not equal to 2, but if we do this, in this case it becomes true because 6 is not equal to 5, right? But when we do 5 not equal to 5 and we say false because 5 is equal to 5, so there's also greater than. We could have greater than like this. Is 5 greater than 5? No. But when we say 6 greater than 5, it says true, right? So we also have less than, right? 6 lesser than 5 is false. 6 greater than 5 is true. We have greater than or equal to, right? It's showing true because this checks is 6 greater than or equal to 5, because 6 is greater than 5 is going to evaluate to true, right? And if you have 5 too, it's also going to evaluate to true because 5 is also lesser than or equal to 5, Same with 6, you can see that here. So if we have lesser than or equal to, this will equate to false because 6 is neither lesser than or equal to 5. But if we have 5 here, it will equate to this. And even if we have 4, it's still going to equate to that, right? So basically, that's how that works for logical operators, right? For relational operators, sorry. So what about logical operators? What are logical operators? Logical operators are things we can use to check, things we can also use to check two conditions to see if they are true, right? And then that will make more sense when it comes to the if part, if statement. So I'm going to show more of that, right? But we can actually work on something. So let's say print, right? 5 equal to 5 and 4 equal to 4. What does this mean? So it's actually checking to say, hey, is 5, if 5 is equal to 5 and 4 is equal to 4, right? So it's going to check if now this entire statement is only going to equate to true if this is equal to this and this is equal to this. Let's see if that will show true, right? So look, you can see that it's showing true. So immediately we say 6 equal to 5 and 4 equal to 4. It's going to equate to false because 6 is not equal to 5. So these two conditions are not true. But immediately we change this, right? Immediately we change this to or. You can see it's saying true because even if this condition is not true, this condition is true. So hence the entire thing equates to true, right? So we're actually going to look at lists, right? So we're going to look at lists. What are lists, right? So that the same analogy of the same example of being a chef, right? So if you want to cook, let's assume you have a basket, right, where you keep onions. So in that basket, every single item there are onions. So that's like a basket of onions, right? So that's what lists are. Lists are used to store a collection of items, right? In that, right? So let's create a list. Right? Let's say we want to create a list of numbers, right? So we say list, and we say integer. If you want to create a list of integer, you write the list keyword, you write the type, and then you put that, and we say numbers equal to. So we use the equal to. This is the name. This is the name of the variable. I'll say 1, right? Let's say 2, 3, 4, and 5. So we use commas to separate their values, and because they have type integer, you actually have this, right? So you can't come and put string here. It's not going to go because this is actually of type integers here, right? So when we have this, we have 5 elements in this list, right? 5 elements in that list, but the first element here has an index of 0. This has 1, 2, 3, 4, and we can show that if we say print numbers and we put 0, you see that, right? So it shows here, and you can see 1. If I change this to 1, it's going to change to 2, right? So basically that's how you can actually create lists, right? You could have a list of strings too. You could say list string, you could say list string, and you could say countries. Let's say countries equal to USA, and then we say USA, Canada, and the same thing applies to that too, right? So we have this, and we can also print countries, right? Countries, and we'd say that would equate to this. So if we want to count the items there, we can just say countries dot length, right? And it's going to give us the total number of items inside that country. So you can see that is equates to 2, right? So that is that on lists, right? So basically this is just the basic stuff on lists, because we're trying to keep the video as basic, the tutorial as basic as possible. So we're going to look at something called maps, right? And we're going to look at maps. So how does maps work? So maps kind of like stores is a kind of like variable that can store things in like list and like a key and value pair, right? What do I mean by key and value pair? Let's first create one. So we'll say keyword map, and we say string, right? So the key is going to be a stuff of type string, and the value is going to be of type integer, and we give the map a name. Let's just say ages, and we do this, right? So when we do that, if you look at what I'm about to do, Alice, and I put 30, right? So what does this essentially mean? This is a map. I'm creating a map, and it's going to have the key as a string and the value of type integer. So key is a string and the value is of integer, and I have the variable name ages, right? So if I want to actually access Alice's value, right? How do I access it? If I say print and I say if I say ages and I say Alice, watch what is going to happen. Oh, no, sorry about that. So watch what is going to happen, right? If I say print execute, you can see it showing 30, which is Alice's age. Let's say I have Bob and I put 40 and I say Bob, right? And I say execute, right? So you can see that. So that's how I can actually access all of that, right? So that's how that works. So now we're going to look at control structures in that programming. And what are control structures? Let's assume that this is how I like to put it, right? Control structures are basically just ways you can transfer the execution of your code from one part to another. Okay, let's give an example, right? So let's assume you get a phone call, and let's assume at the moment there's a particular person you don't want to talk to at the moment, right? Let's assume there's a particular person you don't want to talk to at the moment, right? Um, let's assume there's a particular person you don't want to talk to at the moment. That person is calling you, right? So what would you do? So if the phone rings, you would definitely just ignore the person, right? But let's assume it's not the person now, another person calls. You basically want to like answer the call, right? So if the person calls you and you don't want to answer that person, you will just ignore the call. But if it's somebody else, you want to answer the call. So let's actually give that a shot and see how that goes, right? So let's create a string, and we'll say string name equal to John, right? And we say if, right? If a condition, we check the condition, right? We say if name is equal to John, right? And we say print do not pick, right? So this is how we do it, right? And please note every statement has to end with a semicolon. So when we execute this, right? So you see that do not pick. So once his name changes to James, right? You can see it does nothing. But let's look at the scenario now. Let's assume, you can see now we want something to happen if it's not John. So we say else, we say print pick, right? And then let's run this. So you can see how James now is showing pick. But let's assume if it's John, do not speak. If it's James, then we should leave a message, right? But any other person, just answer, right? So we'll say if name is equal to John, do not speak. Else if we'll put the condition name equal to if name is equal to James, we say, what do we say? If name is equal to James, we say leave a message. Let's leave a message. Else pick, print pick, right? So how would that work? Let's run this now, right? So currently the name is James. So what does it say? It's going to say leave a message, right? When we change this to John, we say do not pick. When we change this to Frank, it becomes pick. So you can see how actually that works. So that's the if, else, if, and else, condition. So we're going to look at loops, right? So sometimes you actually want code to run repeatedly. Sometimes you want code to run repeatedly based on the condition, right? So this is what I mean, right? um it's just like you have your mobile device and you're connected to the internet. So if you're on any social, let's say you're on WhatsApp, right? If somebody sends you a message on WhatsApp, provided you're connected to the internet and that person is not blocked, you should be able to receive the message, right? So, but that should happen um, only if the person um, is connected to the internet. So while that person is connected, it's going to keep receiving messages, right? So that's how we look at that. So it's going to run repeatedly, right? So how do we do that? So we can say there's while loop. We can use a while. We can say while a condition is true, execute something. But there has to be a condition that is going to make it false, right? So we say integer x equal to 0, and we can say while x is lesser than 5, print x, and then we say x plus plus, right? And we run this. Let's execute this. So you can see that it ran 5 times, right? 0, 1, 2, 3, 4, right? It ran 5 times. And that's because this condition was 0 the first time it ran. This if essentially still means x is equal to x plus 1. So it's like saying, oh, what that? So it's like saying each time you actually run it, add 1 to x, store it as a new value of x, and then incrementing it like that, right? So, but before we actually get to the for loop, there's something I talked about showing how we can use something like this here, this and here, or and or something like that. So, let's say we have an age, right? We can say and let's say and we have age up here, right? We have an age, I believe so. Okay, not age variable. Let's say age is greater than 30, right? So now let's see, right? Let's have an age variable here. We say age, integer age, equal to 35, right? So in this case, it's going to check if John's name, if it's John and his age is greater than 30, right? Which in this case, age is greater than 30, it's going to run to not pick. So in this case, let's put it as John, right? And then when we do that, you can see it's still running that. So basically, that's just showing that, right? With this. All right, so let's look at the while loop, right? So we can look let's look at the for loop again. For loop, so for and while are basically very similar, and this is how the for works. So you have a for statement and you declare the variable in here. You could say integer k equal to 0, and then you say while k is lesser than 5, and then you say k plus plus, right? So you would say, let's say print k, and then if we run that, you would essentially see, right? So you have 0, 1, 2, 3, 4. It's run 5 times, and we have this like this, right? So you can see the similarities between while, right, and for. So you have this integer x equal to 0, integer k equal to 0, while x is less than 5, while k is less than 5, right? Print this, right? And we have this plus plus, we have k plus plus, right? Okay, so let's look at something else. We can actually look through a list, right? So we have a list here, and we have countries. So if we copy these countries, right? Let's create another for loop, and we say for integer l equal to 0, l lesser than countries dot length l plus plus, and then we do this. We say print countries bracket l, right? And then when we print execute, you can see it's through USA and Canada. So that's one way we can actually look through items, right? In that manner. So we are going to look at functions. We're going to look at functions, right? So basically, what are functions, right? So functions, these are like to explain functions. So functions are block of like code that you save in memory that you can actually like execute later on, right? What do I mean by that? Okay, what do I mean by that? All right, so it's like work when you have, let's say you have younger ones and you want to send them on errands, right? So let's assume there's a particular type of bread you like to buy, and that bread, you've already told them before, hey, whenever I want to buy bread, this is the bread I definitely want to buy, this is the price, and this is why I want you to buy that bread. So they know, you just say, hey, you call the person's name, you say, John, hey, John, go get me bread. So John knows that anytime you tell him to go get him bread, go get you bread, it's basically saying, go buy me this particular bread from this particular store, and this is the price. So when you're coming back, is when he's coming back, he's expecting the bread or the money back if the bread is not available or something. So basically that's a function, but you won't see John going to buy bread all the time. He's only going to buy bread when he has been instructed to go and buy bread. So that's how that works, right? So how do we create a function, right? So we create a function using void for a function that doesn't really return anything, right? So it doesn't return anything. So let's just say function greet, and this is how you create a function, right? So you would specify void or the type of what data is returning. So we're going to talk about that later, but you specify void if you're not returning anything, then you specify the name of the function, and then you would specify the arguments it's taking or the parameters. If you're not taking any parameters, you just put this, and then you have this curly brackets, right? And then you have all of these. So let's do something. Let's say print. I will say hello, right? So you notice that when I execute, it's not going to show that, right? But when I write this, it's now going to show the hello. Why? Because I'm executing it. So this is why I wrote what I want the grid to do, but it's not doing it yet because I didn't execute it. So the moment I execute it, then it executes, right? That's how that works. That's how functions works, right? So let's look at a function that takes parameters, right? So I could have this greet, and I could say, hey, I want you to greet a particular person, and I say take a string of name, and you would say hello plus the name, right? So what it means here is I'm going to supply the person's name, and if I say Frank, look what was going to happen. So this is how I would specify parameters that I actually want the function to actually have. So let's actually look at functions that return something. So when a function is returning something, you have to specify the data type is returning. So let's assume we have a function that has two numbers. So we have integer, and we'll create the name of the function. Let's just say add, right? And we specify the parameters if it takes any. But in this case, I want it to take two integers, a integer b, that is going to add, and then add them. So when a function is returning something, you use the return keyword, and you have to return what is returning. So in this case, I just wanted to return a plus b, right? And then when I come here and I say print, I could essentially say print add 5 and 10, right? So let's see what happens. So you can see it's showing 15, right? So this is actually returning something, right? And it's returning that, and I could store this in a variable to if I want that, right? So that's how functions that return something actually work for that. So but let's look at classes, right? Let's look at classes. So but before we look at classes, let's look at functions that actually have optional parameters. So but you could have a function that takes two parameters, but one is optional, and I'll give an example. So I'll say void, let's say void greet, let's say, okay, let's just have this. I would say void greet 2, right? And would say it takes a string of name, right? And then let's put the type of greeting we want it to greet, and we would put this right in square bracket. I will say string greeting. This is the type of greeting we want it to actually have, and we'll specify the value of the greeting. So in this case, if the greeting value is not specified, right? If this greeting value is not specified, like you don't specify it, like here for instance, something like that, it's just going to use the default value of hello. So let's just say print, and we say, right, we say we can say greeting, and we can say name. So what did I just do? I introduced this dollar symbol, right? So with this, you don't actually have to be using the plus plus with strings. You can just put this or any other variable, and to just like with strings, like in this case, and to just like put that there. So when we say execute, It's not going to do anything because we're not calling this thing, right? So let's just call it, we say greet to. And watch, I'm only going to specify just one of the arguments, and you see it worked, right? Because we specified the default value for this. So that's how that actually works. So let's look at classes, right? So what is a class essentially in programming, right? What would we say a class is in that programming language? So a class, this is how I like to explain classes, right? So when it comes to classes, you would have let's say a car. So if you want to create a car, right? There are certain things that you expect a car to have, right? A car should have like tires, it should have doors, steering, and things like that, right? So on paper, but all companies have different ways they design cars. So the way Toyota designs its cars, its doors, its tires, is different from the way Mercedes will do theirs, right? But they all have a way they do things, right? So basically that's how it is. But it's a blueprint. So like a class is like that blueprint for creating objects, and an object is something that was created from a class, right? So that's how that works. So how do we create a class? We create a class using the class keyword. So we'd say class, right? And we'll specify the name of the class. So in this case, right? In this case, the when you're creating a class, you use the class keyword, and then the name of the class should start in capital letter, right? That's naming convention. So similar to name normal variables creation, but it should start with the capital letter in this case, right? So this is how you create a class using the class keyword. And then when you have variables inside the class, they call property of the class. But when you have functions inside the class, they are called methods, right? So let's look at this. Okay, so let's create some properties, right? Let's create some properties, and let's say string brand, right? So that's a type string, and we say string model, right? And we say string integer year of the car, right? And let's create a function inside of the class. So we'll say void start. Let's just have this, and we say print, right? So let's just print the brand, right? The brand, and then we say the model is starting, right? Let's just say it's starting, right? So when we want to run this actually, right? And then when we want to run this, we want to create an object, right? So this is how we create the object, right? So we'll use the name of the class, right? We want to create a class, a car object, and then we specify the name of the variable, and we'll say equal to, we say car, right? And we do this. So we can specify the values of those variables. So we can say my car dot brand, right? And we'll say equal to, right, Toyota, and we can say my car dot model equal to Corolla, and we can say my car dot year equal to, let's just put 2020, right? And we can say my car dot start to start the car. So what it does is essentially do when we click on execute. All right. All right. So we say let's put let's here. I will say let's see that. All right. So essentially, why that didn't show is because like we didn't put the late keyword here. So late essentially means that hey, the values of these variables are going to be defined much later, right? So we put that here. So you can see that that is running, and you can see that this is actually executing, right? So that's how you can actually create that. So what are constructors really? Like, let's look at constructors. So whenever you see in a class, you have a method that has the same, like this same name with the class, and then has this. It's called a constructor, right? So constructors, like unlike this start that we needed to actually click the right to start to execute. So a constructor basically is a method that gets called up automatically, right? And most times it gets called up when we do this, right? So when you're creating an object, it gets called up automatically. You don't need to like say dot start to like make it get called up, right? So you can use this to initiate certain values, right? To set certain values. For instance, instead of writing these values here, right, I could decide to do something. I could decide to say, hey, it's going to be expecting um string, let's say string A, and then we say string B, and then we say integer C, right? And we say A is equal to and we say this dot brand is equal to A, and we say this dot model is equal to B, and we say this dot ye is equal to C, right? So when we do that, we don't need to specify all of this again. Let's just remove all of this, and then we just come here and we say specify Toyota, and we specify Corolla, and we specify 2020. Let's see how that goes. So you can see that, right? So I didn't have to like specify the values here. They automatically got called up, right? And this entire thing around here. So let's do something now. Let's say, okay, this is a shorter way of doing it. So we could say car, and then we say this dot brand, and then we say this dot model, and then we say this dot yeah. So what does this essentially mean here, right? So what this means is like this particular class, right? The model, it looks for a property that has that brand name. So that's how that works. So by the time we do this, right, you can see that it does the same thing. So it's like a shorter way of actually doing it. It does the same thing, right? So that is that for constructors, right? Okay, so we're going to look at some properties of object-oriented programming that makes it. Object-oriented programming has like some key properties like inheritance, encapsulation, abstraction, and polymorphism, right? So we're going to look at those properties right now. Okay, so let's start from inheritance, right? So this is a structure for a car, right? Or let's create something now. Okay, so this is a structure for a car. But this is how inheritance works. Let's say children inherit properties of their parents, right? So they inherit the skin color, the face, the looks, and things like that. So that's what inheritance is all about. It's about inheriting properties of the parents, right? Something like that. So we could do something, right? We could say we could do something, and we could say let's create a new car instance. So I just comment all of this out to show this, and let me just comment this out, right? So let me just comment this out, right? So if I wanted to like, let's create a new class, and we say class vehicle, right? So I want to create a new class vehicle, and let's say string, let's create a string and say brand, right? Then we say vehicle, right? So that's a constructor, this dot brand, right? So whatever you specify is a brand, and let's say void honk, right? And then we have let's have a print statement that says the brand, the brand vehicle is honking. And then when we've done that, let's create a class car, and then when you want to inherit the vehicle properties, you use the keyword extends, and we say vehicle, right? And then we say string, right? Model, that's its own property. And let's create a constructor for the car. We say string brand, right? And we say this dot model, right? That is for the model of this car. And then we do something. We say super brand, right? And let's have a function void, and we say start, right? And we say let's just have a print statement that says, hey, oh, sorry about this here. Print statement that says, hey, right? The brand and the model is starting, right? And so let me explain all of this before we actually execute it. So this is a class vehicle, and it has a property brand, and when you initiate the vehicle, you have to initiate it's going to set the brand, and we have a function void that says, hey, the brand vehicle is honking, right? So when we say class car extends vehicle, right? So you're saying that this car extends the vehicle, is inheriting properties of the vehicle, and it's going to have its own model, right? But now the brand of the car wasn't specified. It's not going to be specified when we're creating a class. It's going to actually inherit, right, the brand from here, right, of the vehicle, right? So the whatever we set here as the vehicle, right, is going to be used for this, right? Something like that. And then this model, right, is going to be set here as the model, right? So what do I mean by that, right? So let's actually create something. Let's create something. So let's create a car now. So we say car, no, not here. Let's say okay, I have this car here, or let's say let me comment this out. And then let's say my car is equal to car, and we say Toyota, and then we say Corolla as the brand, because we have to specify that, and we say my car dot start, right? So you see that it's going to start the car, and when we say my car dot honk, right? So because I'm trying to make this I want to make this much easier to understand. Okay, you know what? Let me just make it easier to understand, right? So let me just get rid of all of this, and let's just say the vehicle is honking, right? The vehicle is honking, right? And then let's just say this, right? You specify the model. Let's just get rid of all of this, and then this dot model, and we say let's just say let's just remove these two, right? No need for that. And immediately we say the car is starting, right? So this is honk, this is start, right? So with this, you can see that when we have a new car, we don't need all of this anymore. We created the car, so we can access the start because the start is inside the car class, but there is no honk inside the vehicle. So how can we access it? So the car can actually access it because the car is extending the vehicle. So when we click execute, so you can see that the car is starting, which is running this, and then the vehicle is honking because it's inheriting this vehicle, so it can access that there. So that is that for inheritance, right? So let's look at encapsulation, right? So let's look at a case where you want like set properties of a class to be like private and hidden from the outside world. Let's use it that way. So let's create a new let's look at something, right? So let's say if I wanted to encapsulate the brand, let's say string brand, right? And I say brand is equal to brand, let's just use is equal to Toyota, right? Good. And I say string brand is equal to Toyota, right? So if you try to access this like brand outside of this class, say you come out here and you try to do something like um print, right, and say my car dot brand, and that should give an error really. So let's see. All right, so it's actually run string brand, let's go vehicle, added string brand, um all right, so we look at this and then we say string brand, and we say brand. Okay, so this vehicle, right, string brand Toyota, right. So let's say we actually, okay, let's see, we decide we want to change this and we say print brand equal to Benz, and let's see how that goes, right, and we execute. All right, that's accessing that. So string brand, I'll look at this okay, all right. So but basically, I guess it's basically because this is an online compiler, but in essence you wouldn't be able to access like that property from there, right? You won't be able to access that property from there, so it will give you an error if you are trying to manipulate that or change that. So in essence, if you want to like access that property, right, you would have to use getters and setters. So you would have something like, let's say void, right, and you would say set brand, right, set brand, and it's going to take like a string and you would say a, right, and when you do that you will now say, okay, hey, I want this dot brand to be equal to, you know, a, and then you would have string, right, string get brand to get the value of the brand, and then you could just have an arrow function that essentially does what does it say? It's just going to return this dot underscore brand. So that's how like something like that work. And what is an arrow function? You know, let's look at this statement here. So you see, where in this kind of place where we have something like this, so if we wanted to simplify this entire thing because it has just one statement, we could say integer add, and we would say integer a, and we would say integer b, and we would have an arrow function like this, right, and we would say a plus b. So they're essentially the same thing, so to say, right? So that's what that is, right, about. So that's that on inheritance and encapsulation, right? So we're going to quickly look at polymorphism, right? So polymorphism is like a case where you, let's say, like for instance, you could have, imagine okay, you know what, you have an animal. Animals make sound, right? So an animal makes a sound, but a dog makes a different sound and a cat makes a different sound, right? So in that case, let's look at how that works. So we take class animal, and when we say class animal, right, so basically let's just say void sound, and we say print the animal is making sound, right, and then we would say class dog extends animal, and then when we do that, we say void sound, the same variable name, I will say print, right, the animal is barking, right? Okay, I keep doing that, sorry. So if we execute this, right, if we come here and we say, hey, we create a new animal, let's create a new dog, we say dog, my dog equal to new dog, right, equal to dog, right, sorry, right, and we would say my dog, right, dot sound. So you know, we have we have this here, right? So because it's extending this, we have this, but it's not going to show animal. The animal is making a sound. What is going to show? It's going to show the animal is barking, right? So when we execute this, you can see that the animal is barking. But so I don't. Let's say I didn't put this, right? I just put this like this, and I executed this. You see the animal is making a sound. So that's what polymorphism is all about, right? Basically. So we're going to look at abstract classes, right? So this is what I would say. Um, so have you, let's say assume you work you have a car company, right? And there's a design for the car that you people would never really make, right? But anytime you want to make a new car, you go and check the design of the car and look at what you have for some of the designs and take some of the ideas from there and implement it on the new car, right? So that's what basically like abstract classes are like. So to create an abstract class, you use the word abstract class, right? And let's say abstract class, right? Um, let's say abstract class shape, right? Shape, and then we say void draw. So you actually don't initiate, you don't instantiate abstract classes. They are there, right? So you just use them as a blueprint to create something else, do something else in another class. So let's say class circle, and we say extends shape. Um, right. So when we have the override, because we're trying to override what the other one does, and we say void draw, right? And we say print, right? We say drawing a circle, right? Drawing a circle, right? So let's do the same thing for basically a square. Say square, and we say drawing a square. So when we run this, right? So we say circle and square, and we have draw, right? Circle and square. So let's say circle, right? Circle, right? Or let's do it this way, right? Let's do it this way. So let's see. Um. Okay. Right. So all right. So let's create a new circle, right? So let's say circle, right? Circle, my circle equals to circle, right? And then we say my circle dot draw. And when we do that, you see drawing a circle. When we do that for circle, we do that for square, right? Square. I would have, so say square. I would say my square. Say my square. And we execute. You can see that. So basically, this is like a very good start foundation for this, is like a foundation for that, right? So if you understood this, then it gives you a good head start in that, right? So thank you for your time and do enjoy the rest of your day.